Hello, welcome to this session. In this session, you're going to learn about how the virtual address can be translated into the physical address in RISC-V architecture. So in this lecture, you're going to explore the three important features to understand how this virtual address can be translated. The first thing you have to understand is the multi-level page translation. As you can see in the 6.4 execution environment, the multi-level page translation works. As you can see, there are three different levels of the page table that is used to convert the virtual address to the physical address. So there are the two types of the page table. This page table indicate the point to the next level page table. This page table indicate, as you can see, second level page table, and this second level page table indicate the third level of page table. So this type of page table is called non-leaf page table, and this page table contains the physical address information. This type of page table is called the leaf page table. So it is important to understand the type of their page table. And another important thing you need to understand is the data structure of the page table entry. Inside the page table, you can find out the data inside the page table. That is called page table entry. The data structure and layout of the page table entries can be identified as seen in this slide. So they are the two parts of the page table entry. The first part is the flag information, that is about attribute of page table entry. This attribute starts from 0 to 9th bit. So we are write X, those kind of the page table flag information to check whether the virtual address is valid or not. And there's another part of the page table entry that is about physical page number. The physical page number is placed in 10th to 53rd bit inside the page table entry. So this layout can be identified in every page table. So this red box is about the page table entry. So if you look at the data in the more detail, you can find out this kind of layout. The third important background knowledge is about how the virtual address can be used as the index to find out page table entry. So here is the example, the virtual address to be translated. So this is a virtual address. As you can see, this virtual address is in the hexadecimal format. As know that if you look at the kernel log, or if you make use of any debugging tool, address can be represented using hexadecimal format. But if you would like to learn about how the virtual address can be handled, we need to think about the virtual address can be viewed based on the binary format, because each bit position of the binary value can be used to the level 3 index, level 2 index, and level 1 index. So this is the binary value from this address. This address is in hexadecimal format, and this binary value is in the binary format. Now another important thing you understand is layout of the virtual address. So what you are looking at is the example virtual address that will be translated. But this type of the virtual address is in the hexadecimal format. So if you convert this address into binary format, we can have this data. So this binary data can be split into the specific part, the 0 to 11th bit, and 12 to 20th bit, and 21 to 29th bit, and 30 to 38th bit. So each the bit pair represent the specific operation during the multi-level page translation. As for 0 to 11th bit, so this value is moved to this position. This binary value is only used as offset. So in other words, this offset does not affect the virtual address translation. And here, 12 to the 20th bit, binary value inside this bit pair is used as the level 3 index for multi-level translation. So in this slide, as you can see, the value of the 12 to 20th bit can be used to find out the address of the page table entry for third level page table. And about the 20th and 29th bit pair is used to calculate the page table entry. So it is used as level 2 index. So this value comes from the binary value. This binary value is converted from this address. So this value is used to calculate the address for page table entry in the second level page table. Now as for this bit pair, starting from 30 to 38, it is used as the level 1 index to calculate the address for the first level page table entry. As you can see, that this value can be used to calculate offset for address the page table entry in the first level page table. So three concepts, as you can see, is important that is discussed in this lecture. So first one is to identify how the page table is organized. As you can see, there are two types of page table. The first one is some non-leaf page table. This page table points to the next level page table. And this page table contains the actual, the physical, so address information. Another important thing you need to understand is the data structure of the page table entry. The page table entry have the two important information. First one is the attribute, the flag information, and the second information is the physical page number. The third important thing is how the virtual address can be handled during the multi-level page translation. As we explore the binary, the value of the virtual address can be used as offset, level 3 index, level 2 index, level 1 index. Now that we understand the basic principle that support the multi-level page translation, the next lecture we will go through the first step, that is to find out the root page table during the multi-level page translation.